Today we're going to take a look at relations and functions, which is covered in section 5.2 of your BJU Press Algebra 1 textbook. You're going to want to go ahead and take a look at the textbook. There are a couple of visual examples and then also some word problems that I'm going to reference in this lesson. So let's begin with talking about a relationship. We want to use the relationship of parent, comma, offspring to state the missing element. So for our first relation, we have dog, comma, so the offspring would be puppy. And the next relationship, we have a blank, comma, and kitten. So the parent is missing, so we would say that's the cat. And then on the last one, we have blank, comma, fawn. So the parent that's missing is deer. So let's try another one. Goat, comma. And so our offspring would be a kid. And then a horse offspring would be a bull. So what we were just doing is we were creating relationships. In mathematics, if we have a relation, if we have an association between two sets of numbers. So we have it looks like the parentheses, we call it an ordered pair. And then so the first number is related to a second number, or first number goes to a second number. It has a pair, it has a match. So specifically, any set of ordered pairs is a relation. So a relation is only going to be a set of ordered pairs, so in groups of two. So it has to be in groups of two to be a relation. So relations can be represented in different ways. The first way is sets of ordered pairs. The second way a relation can be represented is a table. So on a table, you're going to have one column with one set, and then the next column is going to be the second set, and then the rows represent the relationships, so what numbers go with which. The third way a relation can be represented is a graph. So that's where you graph the ordered pairs. A domain is going to be the x-coordinates, or the first elements. So the domain is the first element. So the domain is kind of like where you start, right? And then you have the range, and the range is coming off of the domain. So the range is going to depend on the domain. So you start at your domain, you start at x, and then your range is where the domain is going, okay? So the range is the y-coordinate, or the second number. And the range is actually a set. It's going to be the set of all of the second numbers. So here we have an example. We have a relation, and relations are usually indicated with a capital letter because it's a set. So here's relation A, and it has the ordered pairs -3, 5, 2, 2, 2, 4, and 4, -1. So our domain is the set of our x values. So for domain, we would say D equals, and D is representing domain, so it's set D, equals -3, 2, and 4, because those are the first values, or the x values in our relation. So notice that we order them from least to greatest. That's very important that you do that. And then also, even though 2 appeared twice as an x-coordinate, we only have to write it once when we're writing out our domain. For our range, that's going to be all the y-coordinates. So again, notice that I write them in numerical order. I'm going to write the -1 first because -1 comes before 2, which comes before 4, which comes before 5. A mapping diagram is another way to represent a relation. So a mapping diagram is going to have all of the domain numbers in one circle, and then all of the range values, or the y values, in the second circle. And they're going to be listed from least to greatest from the top to the bottom. And then you're going to draw an arrow from the domain to the range. So notice the arrow goes on the right-hand side pointing to the range, because that shows that the domain goes to the range. The domain goes to the range. And so we match. So since 2 had 2 y values, we're going to have 2 arrows coming out of the 2. And then here's our last one, 4 goes to -1. So this is what a mapping diagram of a relation looks like. So now that we know what a relation is, we're going to talk about a special type of relation, and that's called a function. So in order for it to be a function, it has to be able to function, okay? So that means that every x-coordinate or every domain can only go to one y-coordinate. So think about it like this. Like if you, have domain, right? You have your x's. In order to be in order to be a functional relation, your domain can only go one way, to one range, okay? So your x coordinates can only go to one y coordinate. So just a reminder, functions are relations, but not all relations are functions. So every function, since it is a relation, is going to have a domain and a range. Also, every function can be represented a bunch of different ways. A function can be written as an ordered pairs. It can be written as a table. It can be written as a graph or as a mapping diagram. So there are 4 ways to represent a function. So let's take a look at example 3, where we have -3, 5, 2, 2, 2, 4, and 4, -1. So we already talked about the domain and range for this one, and we're going to say that this relation is not a function. And the reason that it's not a function is because you have a domain value, you have an x that goes to 2 different y values, and that's not okay. So the domain element 2 is paired with 2 different members of the range, which makes it not a function. It's still a relation, but it's not a function. So for this example, we have relation B. So we have 0, 4, -1, 2, 3, 4, and -4, -3. So this one is a function, and you'll be like, well, 4 repeated itself twice, but it's okay because it was the y that repeated. The range where you're going, like you can have 2 different domains going to the same range. That's okay. You just can't have a domain going 2 different ways. So let's take a look at how to write functions. So we were using capital letters to write relations, but if you're going to have a function, we're going to use lowercase letters instead of capital letters. And usually we're going to use the letters F and G to name our functions. So function f, we would say, is 6, 9, 4, 12, and 0, 4. The variable that represents the value of the domain is the independent variable. It's independent because that's what we start with. We're starting with x, and then our range depends on what x is. So just like when we were looking at parent and offspring, in order to determine the offspring, we had to know the parent. We had to know the first part first before we can determine the second part. So the same way with domain, the domain is going to be the x value, or the first coordinate, and that's going to be independent. And it's independent because the second coordinate depends on it. So the second coordinate y depends on the first coordinate, and that makes the y the dependent variable. So we talked about how a function usually is written like as f or a g, a lowercase letter, right? And then we can list the ordered pairs. But another way to have functional notation is, instead of writing y, the y coordinate, we're going to write the notation f parentheses x. This is read f of x. And so the reason that we write it like this is because the y coordinate depends on x. So we can say f, our function, of x. So our function depends on x. So f of x. And f of x is the same as y. So since y is the same as f of x, an ordered pair, which we can write as x comma y, can be rewritten as x comma f of x. So you can write it the same. You can write it both ways. So let's say we have our function 6, 9, 4, 12, and 0, 4. If we want to know what f of 6 is, we're saying what f of x, so that means that 6 is x. And so if 6 is x, then that means our y, our f of 6, is going to be 9. So that's how we determine what f of 6 is we let 6 be x, because we have f of x, and if 6 is x, then that means that y is 9. So f of 4 would be 12, and then f of 0 would be 4. So in example 4 in your textbook, it's going to have a word problem and a graph for you to look at. And you'll notice that the points, they kind of come in pairs of points. And our question is that, are these ordered pairs a relation? And the answer would be yes, because any set of ordered pairs is going to be a relation. So that's fine. The next question is, what is the domain of our set? So if you notice, our domain is only the numbers 0 to 12. So for our domain, we can write it like this. D is equal to, so domain, because it's a set, is equal to, and then we'll have our set brackets, the numbers between 0 and 12. So we'll write 0, 1, 2, 3, 1, 2, and we can use the ellipses, which is those 3 little dots, to go dot, 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 comma, and then 12. So we don't actually have to write all the numbers 1 through 12. So these are the values of the domain, and those are the independent variables. And then the range, which is the y values, is going to be 0, 2, 4, dot, 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 16. So it's all the even numbers between 0 and 16. And those are the values of the dependent variable, or the y values, right? So the next question is, are these ordered pairs a function? And the answer is yes, it is a function, because every domain value has exactly one y value. So no element of the domain is repeated. So no element of the domain, no x value, no independent variable relates to more than one element of the range. So the range can repeat, but the domain cannot. All right, go try some problems on your own.